Good afternoon, everybody, from the Johnson Space Center here in Houston, Texas. I'm Josh Byerly. We'd like to welcome you to today's news conference as we take a look at the upcoming historic demonstration mission by SpaceX to the International Space Station. We are joined by an entire panel today, which includes Bill Gerstenmaier, NASA's Associate Administrator for Human Exploration and Operations. We also have Mike Suffredini, the Program Manager for the International Space Station. We are also joined by Alan Lindemoyer, NASA's Commercial Orbital Transportation Services Program Manager, as well as Elon Musk, the Chief Executive Officer and Chief Designer for SpaceX. And finally, we have Holly Ridings, who is the NASA Flight Director, who will be on console during the upcoming flight. We'll start off with Bill.
Thanks, Josh. Today we did the flight readiness review for the SpaceX Dragon flight. This was not a shuttle flight review in the sense that we didn't really look at all the aspects of the launch. We really just focused on the ISS portion of the launch. And this is very similar to what we've done in the past for the automated transfer vehicle and also for the Japanese transfer vehicle, the HTV. What we do in the review is we make sure that the station is ready to receive the vehicles, that the teams are trained, that the crew on orbit is ready, that we thought about all the contingencies that could occur, and we're really ready to go through the demonstration mission. And again, I think the teams are very well prepared. The SpaceX team gave us a nice kind of introductory review of what they've done in their preparations. It was a very thorough discussion by the SpaceX team. They've done a tremendous amount of work getting ready to get to this point. They've done a lot of work in terms of both hardware, getting it ready to go fly, getting the software ready to go fly. I was very impressed with the overall work. Again, I think they've made tremendous progress as a team. So they've got one more long simulation to go do, one more simulation to do, and Holly will probably talk about that some more. There's still some work we need to do, some more software testing that needs to get done, some other activities. Everything looks good as we head towards the April 30th launch date, but I would caution us all that there's still quite a bit of work that needs to be done. There's some things we've got to do on our side to validate some software and things after the SpaceX team completes, and our teams will have to go look at that data and then make sure that it's all okay. So I think there's a good chance to make the 30th. We'll continue to work through this stuff over the next week or so. On the 23rd of April, we'll get back together again and just kind of assess where we are overall to see how things are moving forward. But again, tremendous progress by the teams. I was very impressed with the discussion between the NASA teams and the SpaceX teams. When I hear the discussion back and forth, it's really one team. They're really focused on how do we deliver cargo to space station, how do we get ready for this next phase, and these teams have worked just phenomenally well together. So with that kind of attitude, I look forward to good activities as we move towards the launch. So thank you. Mike?
Well, good afternoon. We're always excited when we have a vehicle coming to ISS, but this will be one of those historic launches with the first commercial vehicle coming to ISS to provide supplies, not only for this particular flight, which is a demonstration flight, but really for the long term. This is the beginning of a long-term effort to have the commercial vehicles supply the ISS, which is a critical need for the program. As Bill said, we had a successful flight readiness review, and then prior to that, the program has what we call a stage ops readiness review. And at that time, what we verify in this new world order is really safety of the vehicle within a sphere around the ISS. We call it the approach ellipsoid, and it's about 2 kilometers by 4 kilometers around the ISS. And the requirements we levy on the SpaceX company and any of the vehicles that want to do a burn that enters them into or aims them to come into that ellipsoid requires that they meet our requirements. And all of those requirements are built around safety of the vehicles and safety of the crew themselves. And so we have spent the last couple of years, several months with our SpaceX colleagues working through the verifications, all of the requirements that had to be met, the testing that we dictated, but also the testing they did on their own to validate the performance of the vehicle. And then as this part of the process, as we get closer to launch, we're cleaning up our verifications where they complete testing, they send the reports to say this is what occurred during the test, we review the reports, we review the data, and confirm that the vehicle's ready to go. So at this stage of preparations, as we get close to a potential April 30th launch, we're in good shape. We still have some what we refer to as non-standard open work, and that just means there's some of the verification closures need to be completed. They're related to hardware in the loop type testing. It's where you get the hardware and the software together and make sure they operate the way you expect. So we have the last little bit of that testing to go, and then our SpaceX colleagues will submit their reports to us based on the plan we have, and we'll review those, and assuming everything's fine, we'll be ready for the launch. What is unique about this, however, is you notice I didn't say we had any requirements for mission success, and that's what our SpaceX colleagues have been working on, and Bill referred to, since we're not responsible for the ascent phase or even the early on orbit phase. This is the responsibility of our SpaceX colleagues, and we've left it to them to define their requirements and then meet the requirements prior to launch. And it's been a learning experience, I think, for both NASA and SpaceX. We've really grown together as two organizations, and I would say not only is the logistics that this vehicle will bring, not only this flight but in subsequent flights, important to this program, but I think the relationship between a company like SpaceX and NASA in terms of our design engineers and even us program managers have learned a lot from one another, and so that's been a great benefit for us as a program. Quickly, the SpaceX will bring up this vehicle, even though it's a demo flight, will bring up 521 kilograms of cargo to the ISS, so we are going to utilize the flight for real hardware that is necessary for ISS. And in addition to that, and an important aspect, unique aspect of the SpaceX will be the return of cargo, and we have about 660 kilograms of cargo that will be returned. Some of it we would like to get back and refurbish for subsequent flights. And so this is a very important flight for us, and we're utilizing it as such. However, each piece of hardware that's going up and each piece we've put on there to come home, we did do an assessment. Since this is a demo flight, we did an assessment and said, if things didn't quite work out, is that okay? And we didn't put anything on the vehicle we didn't think that we could stand to not get home. But it is always an advantage to us whenever we can try to get additional information, and that's what we focused on this flight in the return manifest. Just real quickly, I want to talk about where we are in space station on orbit relative to this flight and all the other work. The crew has been focusing on research, as we've talked about a lot over the last several get-togethers, and as we approach this period that includes the SpaceX launch and berthing, we have a number of activities going on. We have the 47P launch that's scheduled next on April the 20th, and it will dock to the ISS on the 22nd. Shortly after that, the crew will return home. Dan and Anton and Anatoly will come home on the 27th of April. And then after that, we'll prepare Don and Andre will prepare for the berthing of the SpaceX vehicle. And prior to that time, I think Holly might touch on a little bit, we've done the prep work. The crew actually is getting additional training on orbit. But not only do they need to do that training for what's going to happen on the 3rd of May, but they also have to do all the work they need to do to get the other crew ready to come home, and also to have the docking of this 47 Progress. And then after the SpaceX gets there, we have the next Soyuz that's going to come up and dock, and then after that, we'll have the release and return of the SpaceX demo vehicle. So you can see that while we are going to focus on getting this new vehicle there, it is a workhorse for us. It is intended to be a logistics vehicle that gets to station, it delivers its cargo, and then it departs so the next vehicle can take its slot, or so that the crew then can focus on research. And it will begin that way with the very first flight. We're not opening up a big hole and having this demo take effect. It's an integrated part of an overall plan, and we intend to treat it as such. And so we're looking very forward to that flight. And with that, I'll hand it over to Al Lindemore.
Okay, thank you, Mike. Good afternoon, everybody. So when the decision was made to retire the shuttle and continue our exploration program, we very much would have liked to purchase commercial services to resupply the space station. But those capabilities just simply didn't exist in the U.S. markets. So we decided to think like an investor. We wanted to become a consumer of services rather than a customer of requirements. That would be our more traditional approach. Write our requirements, go hire a prime contractor, and develop the capability. But we believed that these capabilities were within the grasp of U.S. commercial industry. So 5 years ago, we set these objectives for the program. You could pull those up if you would. We had to learn to think like an investor. We wanted to place strategic financial investments to help stimulate the commercial space industry. Then we put some structure around those investments where we developed the program to have the companies demonstrate these capabilities with the goal of achieving safe, reliable, and cost-effective services. We were looking to help lower the cost of access to space. We believed that that would, of course, help us out and also be the key to opening up new markets in low Earth orbit. And the third thing we said is, if we're successful in placing these investments and have solid commercial partners, well, then it's important to be able to sustain that new capability, sustain the new market that's created, and NASA would become a customer for those services. And by reducing the cost, we hope that this will also be sustained by opening up new markets by this lower cost access to space. Well, we followed through on that promise. In December of 2008, not only had we awarded the Space Act agreements for the development program for the new commercial services, but we also awarded the resupply contracts for the space stations. So we certainly followed through our promise to become a very interested customer. Next chart. So this is a summary of the new capabilities we're about to see demonstrated with SpaceX. We did sign the agreement with SpaceX in August of 2006. We've monitored SpaceX's performance over the years through a series of pre-negotiated milestones. And this is also a difference that from our traditional approach of regular contracting. In this case, we only made payments after the milestone was achieved. It was up to SpaceX to provide the necessary funding and resources necessary to meet each one of these incremental milestones. And then when they were successfully made, we made our incremental payments. To date, we've paid 37 out of a total of 40 for $381 million of investment out of a possible $396 million total on the agreement. All the milestones are completed except for the last three, this upcoming demonstration flight. This is the second demonstration under our Space Act agreement. The first demonstration flight was completed for our program in December of 2010. A very successful first flight of the Dragon spacecraft on the Falcon 9, an orbital demonstration and return. Next chart, please. In addition, we also have a commercial partnership with Orbital Sciences. This is a very similar Space Act agreement arrangement with Orbital. They started a year and a half later than our agreement with SpaceX, and they're also making very good progress. We'll see Orbital planning to fly later this year. They'll be starting with a maiden flight of their new launch vehicle, the Antares launch vehicle. This will be launched out of the brand new launch pad at Wallops Island, Virginia, off the eastern shore of Virginia. So we're looking for that later in the year. They have 5 milestones left: the completion of the first stage assembly, the maiden test flight. Then they will complete the vehicle for the demonstration to the International Space Station. And that agreement will finish up with the flight to the station later in the year as well. Next chart. So this is a history of the performance of the milestones that we established in the agreement. Up top, you'll see SpaceX agreement starting in 2006. It started with the series of design reviews, system requirements reviews, preliminary design reviews, moving into a critical design phase. Then SpaceX moved on to the test and production phase. We saw the maiden test flight in 2010. And then last year, we requested and received additional funding for our program to help improve the chances of mission success for our program. So we worked together, SpaceX and I, and we came up with a series of additional milestones to add additional testing to help improve the chance of mission success. This was primarily system-level testing. Last year, SpaceX completed system-level thermal vacuum tests, electromagnetic interference tests, acoustic testing, and all that was of very high importance to us. There was a lot of learning going on, and I think it is going to be very, very valuable to us. So that was completed last year. And now we're moving into the finishing up our demonstration phase with the demonstration to the station. So let's talk about the objectives of this flight. We call it C2, that stands for COTS 2. It's the COTS Demonstration 2 flight. This flight originally was to be a flyby to the station. That is, it was to do a rendezvous with the space station, and then it is to do a flyby beneath the station, no closer than 2.5 kilometers, or about a mile and a half. And during this period, it is going to execute prerequisite maneuvers that are required before we give the final approval for the final approach and berthing with the space station. These are the same type demonstration objectives that were accomplished with other visiting vehicles to the station, the ATV and the HTV, all demonstrated before the final approach that they had the ability to do GPS navigation, relative navigation, absolute navigation, the ability to do abort maneuvers, the ability to free drift and hold for a while. These are the requirements that must be achieved before the go is given to do the final approach. That would be a very successful mission under the C2 program, and then it would re-enter and be recovered. SpaceX approached us last year and said they would like to attempt to also complete the berthing, the final approach and berthing to the demonstration on the upcoming flight. So after reviewing the proposal and doing the required safety analysis to be assured that the vehicle and the systems are ready to go, we agreed to give SpaceX that opportunity for actual completing the berthing demonstration on this flight. That will also include demonstrating the LiDAR sensors. Those are the radars and the rendezvous sensors that gives you the range and the range rate information as you approach the station. They'll be doing some close-in retreat demonstrations, hold demonstrations, and finally the vehicle will be captured by the robotic arm and then berthed to the Earth-facing side of the forward node on the station. After about 18 days of demonstrating the transfer of cargo to and from the station, we'll see the Dragon unberth from the station and then return home. We call this mission C2+. It's the C2 mission plus the additional objectives of completing the C3 objectives on this flight. So let's see, if you run the video now, I guess we'll take a look at what we can expect to see. Targeting now for the end of the month, we'll see the Falcon 9 lift off from a beautiful day at the Cape. About 3 minutes later, we'll see the stage separation between the first and upper stages on the Falcon 9. Then about 10 minutes into flight, it'll be in orbit. The Dragon and its trunk will separate from the upper stage. About a minute later, the solar arrays will be deployed. And then it'll begin its phasing maneuvers to the space station. It takes about a day to get to the proper phasing and rendezvous with the station. The second day will be used to complete the demonstration maneuvers I talked about. And if all goes well, SpaceX will re-rendezvous with the station, and on the third day, we'll see the final approach. And the vehicle will be captured by the arm and berthed. This operation takes about 8 hours by the time you get in to the final approach to the actual berthing with the station. After a few weeks on orbit, it'll be unberthed. And then it'll be preparing for a deorbit burn and reentry. About 2 to 4 orbits later, we'll see the Dragon reenter, parachute deploy, and splash down off the coast of California. That would be a very good day. I wanted to thank everybody. We're certainly very excited to be here. This has been a great partnership between NASA and SpaceX. I want to thank my team. Mike Horkachuk, project executive, has been with us since the beginning, and his assistant Warren, who's helped make available the vast resources at NASA to help SpaceX. So thank you. It's been a great partnership. We're really excited and looking forward to the launch. Elon?
All right, well, I'd just like to start off by saying thank you to NASA for giving us this opportunity. As you may have heard me say before, SpaceX wouldn't have been able to get started without the amazing work that NASA has done in the past, and we wouldn't have gotten this far without the help of NASA. So I'd like to be real clear in expressing my appreciation for that. And I'd also like to express a note of appreciation to the American public who are ultimately funding this, and just want people to know that we've really done everything we can to make sure that this mission is going to go well. It's been a huge amount of hard work by the SpaceX team in partnership with NASA, and I think we've got a pretty good shot. But it is worth emphasizing that there is a lot that can go a lot that can go wrong in a mission like this, because you've got to have the success of the rocket, and then you've got to have success of the spacecraft. Now we've launched the rocket twice before, and we've launched the spacecraft once, but they're still relatively new. And then there's the whole proximity operations and berthing system, which is going to be tested for the first time in space. And so there's no space station on the ground. So our work to date has been done by a simulation and by approximating the circumstances that it would find in orbit and approaching the space station. So I think that's just important to appreciate, that this is pretty tricky. And I think also for the public out there, they may not realize that the space station is zooming around the Earth every 90 minutes, and it's going at sort of 17,000 miles an hour. And so you've got to launch up there, and you've got to rendezvous and be tracking the space station to within inches, really. And this is something that's going 12 times faster than a bullet from an assault rifle. So it's hard. But I think we've got a pretty good chance. But there's, like I said, I want to emphasize this. That this is, as has been said by other people in the panel, that this is a test flight. So if we don't succeed in berthing on this mission, then we've got a couple of more missions later this year and I think we'll succeed on one of those. Yeah, so I think we've got some videos of the preparation that we can show. There we have the rocket in the hangar at Cape Canaveral. Dragon spacecraft. Now, one of the things that's worth noting about Dragon is that we've tried to design something that is very similar between cargo transport and astronaut transport. So we expect there to be relatively few differences between the two. There's Dragon mounted on Falcon 9. here we're doing a wet dress rehearsal, which means we load the liquid oxygen and kerosene, the fuel of the rocket, and just make sure everything's okay. And coming up soon, we'll have the static fire, where we'll light the engines and shake things up a little, but keep the rocket held down, and then see if everything's okay before. And we'll spend several days analyzing that information, and if that's looking good, then it'll be okay to launch the rocket in theory. So, do we have another video? Pardon me? Oh, COTS milestones. So we've got one more video to show. So just elements of the rocket and spacecraft being tested. And I think it is worth emphasizing that the Falcon 9 has flown twice before, and Dragon has flown once. So I think a lot of people in the public may not be aware of that. So the thing that's really being tested on this flight, hopefully, is the proximity operations and berthing system. So and there are other things as well, like the solar panels and a few other things. But it's worth noting the rocket has flown twice, and the spacecraft has flown once. All right. Well, with that.
All right. Well, good morning, actually afternoon, everyone. My name is Holly Ridings, and I'm the lead NASA flight director for the SpaceX Dragon demo mission. I'd like to tell you guys today that the operations teams have been working extremely hard for multiple years, really preparing for the launch and leading up to this day so that we could come and explain to you exactly what we've built together. The first part, of course, is when you incorporate a new team, a new partner, in this case, SpaceX, our first commercial partner, into the space station, there's a lot of technical things you do, the nuts and bolts, make sure that we can talk back and forth between the two control teams, the control team in Hawthorne in California at the SpaceX facility, and of course, our team here in Houston, commanding back and forth telemetry, back and forth, and as well as information that can pass all the way from their facility in Hawthorne up to the space station. So we put that infrastructure in place to incorporate them as a new partner. We move on from there really to build the framework of how we're going to fly. This takes multiple years really for their team to learn about the space station, for us to learn about the Dragon. It's really a partnership. They are certainly the experts in the Dragon, we're the experts in the space station, and we treat it as one team. It's two dynamic vehicles flying in space together, and it's extremely important that you communicate and understand each team's roles and responsibilities. As was alluded to earlier, our role here in Houston is really the safety of the crew on board the space station itself, and then the SpaceX Dragon team is responsible for the mission success. And we've built a framework working together where we should be able to get both of those items successfully accomplished. We write documentation, procedures, flight rules, the things you're familiar with the other vehicles that NASA has flown in space, and we make sure that the teams are trained to use all of that information. So we practice using our simulation capability, learning how that process is going to work, coming up with failure scenarios and talking through how we're going to react and recover from those. And again, as was alluded to earlier, we've performed a series of those for all the different phases of the flight. The last simulation, just the final clean run for the polish before we go and fly here shortly, will actually be next week. And so we're really looking forward to doing this run one last time on the ground before we get on orbit. The other big piece of our operations team, of course, is our space station crew, since they will be performing the grapple of the Dragon vehicle, the berthing to the space station. And so that team, our crew team, has been working hard to prepare for this mission as well. The time frame that we're discussing launching in is one in which we've got 2 crew members available to perform the Dragon operations. And so we've spent a lot of time communicating with them, Don Pedret and Andre Kuipers, making sure that they understand exactly what will be expected of them. They, of course, were trained on the ground, but they have been on orbit for a while we've continued to work down here and learn new things. And so we spend a lot of time communicating all of that information to make sure, really, as the third piece of our operations team, they're ready to go for us. So now we're going to kind of walk through the mission that we've put together. So if I could have the first still, please. You can see the different phases of the flight. So we've got our launch, followed by the phasing, where the Dragon's still far away from the space station. As was mentioned earlier, we'll come up and do a fly under of the space station all the way around. We've got some demonstration maneuvers, followed by all of the new activities in the rendezvous and proximity operations, the berthing, finally the departure, re-entry, and recovery. And I've got some graphics in a minute, but before we leave this slide, in terms of roles and responsibilities, really the launch and the phasing piece is, again, SpaceX responsibility until they get close to the space station. That operations team is taking care of the Dragon and designed all of that independently. We have understanding of exactly how that will go, but certainly that's their responsibility. When we come up close to the space station, then the interaction with the NASA team begins, and we've got some gates and some process in place where we make sure that the safety of that space station, our space station, is protected. And again, once the Dragon has left after departure, the SpaceX team takes over again and works with the FAA colleagues and brings the Dragon home and performs the recovery. Again, certainly that has NASA cargo, so we're interested in it, but from an operations sense, the Dragon team performs that function in terms of the departure and the recovery. If we go to the next slide, please. So one of the things that I mentioned was the demonstration objectives. These were touched on a little bit earlier. We do have some demonstrations to really talk about the abort capability. That's one of our primary sort of pieces of our safety infrastructures, the capability to always safely perform an abort where, if there was an issue, the Dragon could fly away from the space station to prevent having any type of collision. And so that's a very important aspect of our safety framework. Different pieces of navigation. As you get closer to the space station, you have to be able to navigate more accurately, and so we make sure that all of those pieces work correctly. Communication, of course, to dynamic vehicles in space need to be able to talk to each other, and then just the general controllability in terms of the guidance and navigation, how the engines work, those type of activities. This has all been tested extensively by the SpaceX team on the ground. Had NASA folks as well involved in the verification, but these are really the very important critical pieces that we want to validate on orbit, look at that capability before we use it in a safety critical situation. So it's really a building block approach where we execute a demonstration objective is what we call it. So a piece of functionality of the spacecraft, make sure it works, and then later in the mission we will need that capability. Let's see, next page. So here's our mission profile. This is obviously a two-dimensional representation of two dynamic vehicles moving very quickly in space, as Elon alluded to. But if you look at the red arrow down in the bottom right-hand corner and think about the Dragon moving in that direction over time, you can see down in the far right-hand corner, that's really the phasing time frame. It's not to scale, so that time frame could be, a day or 2 or 3, depending on exactly how long the Dragon's going to take to phase to the space station. So that capability, again, is the function of the Dragon control team. So the Dragon will come up, finish its phasing, and where the red arrow is kind of pointing at the green line, That's about 10 kilometers underneath the space station, and it'll perform what we call a burn, so turn on its engines, maneuver the spacecraft, and head up that green line towards the space station, ready to perform a fly under of the space station at 2.5 kilometers. And so that fly under is very important to us because it's the first time the Dragon and the space station will communicate with each other, an absolute requirement for proximity operations. It's the first time that the crew on board the ISS will send a command to Dragon and get response. This is just a test command, so it's a light on the Dragon, but it's leading towards the crew potentially needing to send more invasive commands such as a hold or retreat or even an abort later, and command the Dragon when it's at the capture point. We're also gathering navigation data. So the way the two vehicles navigate together is a relative where you get pieces of information from both vehicles and you do a calculation, and then they know exactly where they are in space relative to each other. And so we're gathering information to make sure that navigation system works. So we're flying to the space station, gather all that information. The Dragon's going to head back down to about 10 kilometers below, and then do a big lap around the space station called the fly around, where it comes up the left-hand side of that graphic. It's phased fairly far out in front of the space station by then, greater than 200 kilometers. And so it'll perform, again, a burn, another turn on the engines, and move the spacecraft headed up and over the space station, come across the top of the space station, and then down the backside relative to the graphic, again, fairly far out from the space station, beyond 200 kilometers. So that entire process should take just about a full day, on the order of 22 to 24 hours to complete. Let's see, next slide, please. So now we're kind of back where we started at our red arrow, roughly again that day later, and we're headed again back up to 2.5 kilometers below the space station. Remember, that was the distance that we did the fly under the day before. You can see the green dot. That's where we cross into what we call integrated operations. And so I mentioned earlier sort of the responsibilities of the different team members. Our responsibility in Houston being the safety of the space station and the crew on board the space station. And so when we're inside of integrated operations, which is in close proximity to the space station, the team here in Houston has authority over the mission. Of course, again, we're working as a team and in partnership and communicating with the Dragon team, but we do have the final authority so that we can keep that safety at the very top of the priority list. We've come up to 2.5 kilometers inside of the integrated operations, and now we're going to head up to the 1.4 kilometer. The little dots, the little red dots, again represent burns, or again a time where Dragon will fire its engines and adjust its height relative to the space station, so it's headed up closer to the space station. So now we're flying under at 1.4 kilometers. Again, next red dot, this is our approach initiation. So this is the burn that will take the Dragon on an intercept trajectory with a position directly below the space station. We call it the R bar, so it's the radius of this between the space station and the Earth. If you drew a line from the center of the space station to the center of the Earth, and 350 meters below the space station, you put a little Dragon, that's where it's headed. So it's going to end up in that position, and eventually we'll get to 350, move another 100 meters, and actually pause automatically at the 250 meter hold point. Next page. So now we're up again on the R bar. At 250 meters, the Dragon is holding, and we've got some more of our demonstration objectives that we need to complete. These involve the crew with some of the commanding. So you can see the green Dragon represented on the slide will approach from 250, so it starts moving towards the space station. The crew will then command a retreat, and so it will turn and head back towards that 250 meter hold point. The graphic has all of the Dragon pictures spread out on the left, so you can see the up and back, but they actually all will happen on that R bar line, just forwards and backwards. It's just hard to represent on the slide. So now we've gone to commanded the retreat. We're headed back to 250. Then the Dragon team in Hawthorne will send the Dragon again towards the space station. The crew will tell the Dragon to hold. That'll be at about 220 meters. And so that will be the last of our go-no-go objectives in terms of the demonstration objectives. We do have go-no-go criteria, and that's our terminology that we use in our flight rules. We're here in Mission Control Houston and with Mission Control in Hawthorne at SpaceX, we take a poll and make sure that all of the systems on board the ISS, all the systems on board the Dragon, any type of failure detection, the robotic arm, the cameras, basically everything you need in order to do that next step of the mission is in the configuration you expected. And then after you've had that communication between the two teams and everything is in the proper configuration, then the go is allowing the Dragon to proceed and continue with the next step of the mission. So when we use go, no go terminology, that's exactly what we're talking about. So at this point, we're 220 meters below the space station. We've completed all of our demonstrations. Again, the controllability, the navigation, the abort. We have taken the poll and made sure that we've got all of the functionality we need, and we're headed on up towards the space station again. We're going to cross into what's called the keep out sphere. So it's a 200-meter circle around the space station, which we kind of use as a line of demarcation for us to know that we need all of that functionality checked out before we head past that point. We're going to head all the way to 30 meters. If I could have this slide back, please, might be easier. Thank you. So we're going to head all the way to 30 meters, and the Dragon, again, will automatically stop at 30 meters. We're going to perform another one of those go, no goes, so a poll to make sure we have all the functionality. At this point, the crew is heavily involved with us. They've been monitoring the Dragon, certainly throughout those demonstration objectives where they were sending several commands, and also as the Dragon headed towards the space station with the capability, if necessary, to go ahead and take action, although the Dragon vehicle itself is designed by the SpaceX team to really be very automated and to take care of itself. The crew is really there kind of as a safety net, certainly with the first flight of the demonstration capability. We really would like to make sure we've got all of the crew involved as well as the vehicle itself. So we're at 30 meters, we've taken our poll. Now we're going to head up to the 10-meter point. You may also hear this referred to as the capture point. The Dragon will hold again automatically 10 meters from the space station. Another poll to make sure we've got all of the technical capability required, and then we give a final go for capture. We tell the crew that we are ready for that capture, and then they really take over from that point. They have a command to inhibit the thrusters on the space station, so those will not fire. They'll take the Dragon to what we call free drift, so again, where the thrusters do not fire, and then they will drive the robotic arm, the SSRMS, out and capture the Dragon. Obviously, you don't want thrusters on either spacecraft firing when you've got your robotic arm connecting the two until it's had an opportunity to rigidize, otherwise you might harm it. So that process will be taken care of by the crew. Now we've captured the Dragon successfully. The next couple steps, we are headed towards doing a berthing of the Dragon. We do some system configuration to make sure it's ready to be berthed. We'll make sure that the common berthing mechanism, the passive side that's on the Dragon, is clean of any type of debris. And then we'll head on in robotically with the crew, flying the robotic arm to berth the Dragon to the Node 2 nadir position, again, the Earth-facing position. All of that activity from coming up the 2.5 kilometers all the way up the R-bar takes place in one day. It's a fairly long day. It's about 7.5 hours for that rendezvous and proximity operation. The next morning, we'll get up and open the hatch for the first time and perform the very first cargo transfer. We're going to perform roughly 25 hours of cargo transfer, both unpacking and then packing the Dragon while it is on orbit. And then several weeks later, we'll get the Dragon ready to come on home. If I could have the next slide. And so here's our reentry and recovery. In terms of space station operations, we take the robotic arm and unberth the Dragon from Node 2 Nadir, unberth it from the CBM. We'll hold it out on the end of the robotic arm, make sure it's got all of its navigation capability up and running, and then we release the Dragon. It performs a series of burns, again, maneuvers. There are 3 of them. So one, you can see where the green Dragon is, a second one at kind of the end of that half circle, and then a third one at the end of the second half circle. So a series of 3, we call them departure burns. And then the Dragon will head away from the space station. We check that it is on a safe trajectory away from the space station. And then, as I mentioned earlier, the operations team in Hawthorne then is in control again, of course, of the Dragon in terms of outside of integrated operations. And so they will make sure that it's ready to deorbit and come on home, splash down in the Pacific, and then they've got their recovery operations that they are going to run out to bring the Dragon on into Long Beach.
Well, we're going to start with questions here in Houston, then we'll go down to the Kennedy Space Center, and then we'll go to the phone lines. We have quite a number of people, so we're asking that you stay with one question, one follow-up, and we'll come back here and go back around one more time. We'll start off with Mark.
Thanks. Mark Carreau for Aviation Week and Space Technology. And I wanted to go back to the software validation work. Could you elaborate some on that? And if I understood correctly, you'll have a follow-on to this FRR on about the 23rd. If you could sort of bridge what happens after that to the launch point.
I can do a piece of it, and then Mike and the others can also chime in. There's still some software work that's going on. Some activities are completing in Hawthorne where they're doing hardware in the loop testing to make sure that the software works right with the hardware. Then when they complete those results, they provide test reports and test analysis of that activity back to the NASA team. And the NASA team looks at that to make sure that it all fits and works the way it was supposed to go work. They'll also do some testing with the actual vehicle down in Florida. Well, they'll do the same kind of thing. Well, they actually run through the software with the flight vehicle. And again, those reports come back to the NASA team. We'll take a look at it. We will not do a formal review like we did today of that activity. What we'll do is we think that'll all be okay, but we'll get a report back from the individual teams, the safety folks, the software folks, et cetera. They'll tell us on the 23rd that everything went as planned. There was no surprises, nothing unique there. And then we'll just continue on then towards the launch. And some of the activities that occur towards the launch is there'll be a flight readiness firing of the engines. There'll be hydrazine loading in the Dragon capsule. A lot of activities occur in kind of that final week. SpaceX also does their own internal flight readiness review, and they'll do that on Sunday, the 22nd, just in front of this review. So that'll be one chance for them to go through to make sure all their individual components and systems are ready to go forward. So I would say today we had enough assurance that everything is moving in the right direction. We're heading towards the 30th. We're not completely there. We want to go ahead and get these final checks from the SpaceX team. After those checks are complete and we understand where they all sit, then we'll say collectively this is the right thing to head forward. So we got enough assurance today that the 30th is the right day to head towards, but we still reserve the right to take a look at the data, see what the software does, and see what the teams find as they go do a more in-depth review.
Eric Berger with the Houston Chronicle. A quick question for Alan, then a follow-up for Elon. First of all, Alan, is it accurate to say that NASA has invested $381 million so far in the commercial cargo capabilities for SpaceX?
Yes, that is the total of the 37 milestone payments we've made to SpaceX to date.
Okay. And then for Elon, you're in Texas today, and it's possible that Dragons could launch from Texas in the future. I'm curious what the state and maybe the federal congressional officials need to do to make this an attractive place for you to build a spaceport.
But I don't want us to get too off topic, because I mean, this is really about the upcoming mission to the space station. But we are pretty interested in the possibility of a Texas-based launch site. And I think there's a lot of good action being taken by the local authorities in the Brownsville area in particular. Not that much at the state level. Would certainly appreciate more help at the state level. And then at the federal level, it's not really I think the federal level is relatively different as to what state we launch from. But we thought it was important to look at having a third launch site just to make sure in the future that if we have a lot of missions taking place for commercial satellite launches, as well as launches to the space station for cargo and potentially crew, and then potentially Defense Department missions, that we didn't encounter a launch site constraint. But I should point out also that we're also looking at potentially using one of the shuttle pads at the Cape for crewed flight. So we just want to make sure that we don't in the future encounter launch site constraints. That's really what we're after with that element. So.
Hi, Kevin Quinn with KTRK ABC 13 here in Houston. And maybe this is a question for Elon. I'm not sure. Maybe it's a NASA question. But can you describe, please, specifically weather restrictions that could affect launch and how those would compare, say, to that which was out there for the shuttle program? Are these tighter restrictions? Are they lesser restrictions?
I think they're probably comparable. We definitely want to err on the side of caution, particularly since these are initial flights. But I think they're probably comparable. I mean, I'm not entirely certain, but I think similar.
And I think I would say they're pretty compatible. You see it even in our expendable launch vehicles. We have a lot of trigger lightning rules. Those rules will be the same. We have basically the same visibility rules for the ground observers that are watching the rocket fly, those kind of things. So those are all pretty similar. The winds aloft might have been a little more restrictive for shuttle than they are for the Falcon 9. But other than that, I think they're pretty comparable overall.
Jeremy.
Jeremy Diesel from KHOU. Question for Elon. If this is all successful, everything goes exactly as planned.
That would be awesome.
Right? What becomes the next step, the next timeline, the possibility of seeing a crewed flight?
Assuming this is successful, then we look forward to a steady stream of cargo flights to the space station under our CRS contract. That would be really super great. And then, because we've designed the spacecraft and rocket to be very similar between crew and cargo, we're in the process. We'll be accumulating a lot of knowledge about how how potential crewed flight might work. And if there is an issue, I think there's a good chance we'd uncover it on a cargo flight rather than potentially put crew at risk, which is, I think, pretty helpful. And then we do have to have a separate contract with NASA for adding in the elements necessary for crew transport. And then there's but there are a bunch of additional steps that have to take place there. But we're optimistic that at some point Dragon will be carrying astronauts, and that would be really great.
2 years, 3 years, 5 years, 8 years?
Well, there's a lot of variables between here and there.
Perfect world.
Oh, perfect world? Well, it's probably like 3 years, maybe a little less than 3 years. Yeah, 2.5. Yeah.
Okay. David.
David Hirsch, NHK from Mr. Suffredini first. Given that the ISS is an international collaboration, I wonder if you could give us a sense of what the importance of the international partnership as far as this entire project and the role of international partners in the FRR today.
Yeah, it's twofold. One is the partnership, the entire partnership does benefit from these vehicles, and in fact, all but our Russian colleagues rely on it. We utilize a suite of vehicles in the futures to provide upmass to ISS and its progress, the JAXA HTV, the ESA ATV, and then the 2 commercial vehicles that we're talking about here today. And the lion's share of the upmass will be provided for the USOS segment. The lion's share of the upmass will be provided by these commercial vehicles. So it's very important to the partnership. This FR, just like every FR, has all the partner agencies are represented, and so it's important to them. And they worry about not only the fact will it bring it up, but there are safety implications, there's plume impingement issues, there's EMI, there's all sorts of things that we have to prove to the entire partnership that we meet those requirements. And all of our requirements are meant to protect us from that. and our partners participate in the safety review boards and the analytical process of determining that we're not causing any harm to the rest of the spacecraft. And in fact, part of the responsibility of the U.S. is to ensure the integrated spacecraft is okay. But they would like to see the data, and so we provide the data that's necessary to make them feel comfortable that their element is also safe from those aspects.
Down here. No question? Okay, let's come over here.
Hi, my name is Kensuke Obara from NHK. I hope I can make myself understandable in English, but I would like to ask a question to Mr. Gerstenmaier and Mr. Musk. Everything pretty much seems familiar for a reporter reporting for HTV, and I would really like to ask, what is the connection between this new challenge of SpaceX with the Japanese HTV approach and rendezvous docking? In other words, was there any improvements, or what kind of implications have you had added to this approach for SpaceX? And to Mr. Musk, I think safety is the priority, but as a commercial company, what kind of aims have you tried to implicate into SpaceX's new launch vehicle? And how would this challenge, this new challenge, would, in a sense, add to your overall, I would say, pursuit for that aim, possible?
Yes, first of all, for your first question, I think we learned a lot from the HTV activities. We did a very similar approach when HTV flew the first time. It flew up and it did a series of gates, very similar to what Holly described in a lot of detail here earlier. So the same kind of approach where we verify a capability before we commit to using that capability, that was done with the HTV, and it was a good chance to see how that process worked, how it worked as a team. I would say also Holly's team and the flight controllers, they got familiar with getting that data from an international partner in the case of JAXA. They took that information, they could then digest it, analyze it, compare it, and work with them. So I think working with the international partners gave us a lot of experience of working with a different community that we don't work with every day, that allowed us to learn how to exchange data back and forth, how to communicate, and how to develop the basic procedure that allows us to learn incrementally, that allows us to get into the berthing box to be picked up with the SSRMS. And I think also that the berthing box concept and using the SSRMS to pick up the Dragon, that's very similar to what we did with HTV. And again, that HTV kind of paved the way of seeing how the crew would use the arm, the overlays they use, the camera ops they use. A lot of that was kind of proven the first time through with the HTV flights that are coming up. So we learned a lot from our international partners, and we applied it to the commercial sector and to Dragon, and it made it a lot easier when we come into this flight. It wasn't the first time around we've seen this stuff, we've seen the basic process and procedure, although the vehicle is very different than the Japanese transfer vehicle.
Right. I think we're grateful for the prior work of the HTV as well, because it made things easier for SpaceX to, approach the space station because of some similarities in the way things are done. So that was quite helpful. The way in which Dragon is most significantly different is that it returns to Earth, rather intact. It's got a heat shield and everything, so you can return cargo to Earth. So that's probably the biggest difference. I touched on this briefly earlier, but because there's so many similarities between the cargo version of Dragon and the crew version of Dragon, we're learning a great deal about crew transport when we do a cargo mission. Technically, if you've got a little oxygen bottle and you stow it away on Dragon, you, in theory, be okay. You could go to the space station if you're tucked away in there. So it's kind of neat in that respect, and come back too. And then there's sort of a larger context of SpaceX where we want to keep upgrading the technology and making improvements so that ultimately that there can be journeys beyond the space station. So that's obviously a topic for another day, but I think there's a lot of excitement about that, and we're going to keep improving the Dragon technology. So we have an upgrade plan and everything. So, all right.
Okay, I think that's it from here for now. Let's go down to the Kennedy Space Center in Florida and take questions from there.
Hello, this is Marcia Dunn of the Associated Press with a question for Mr. Musk. There's still a fair number of people not totally on board with the commercial side, especially regarding crew transport, and I'm wondering if you feel a lot of pressure as you go into this last 2 weeks before launch to succeed, and how important is it in your mind to launch successfully into berth on this flight?
Well, there's no question that there's going to be some people who will put, I think, too much weight on this flight because it is explicitly a test flight, and indeed we may not succeed in getting all the way to the space station, as I articulated earlier. But I think it would be a mistake to put too much weight on this flight because there are hopefully going to be 2 more flights later this year to the space station, which will be almost identical configuration. So if this one doesn't succeed in getting to the space station, I'm confident that one of the other 2 will. And we'll work with NASA to resolve any issues and then figure those out and then get to the space station. But there should be no doubt about our resolve that we will get to the space station, whether it's on this mission or on a future one. And I don't think that if this mission doesn't get all the way there, that it should be taken as a verdict on commercial crew transport. I think that just wouldn't be right. Although there will be some people who try to do that.
Thank you. And if this does go well, what is your timeline for those next 2 flights?
Well, that's something we have to work with NASA on. But I think there'll probably be one in the summer and one at the end of the year. But that timing remains to be worked out with NASA.
This is Philip Sloss with NASASpaceflight.com. I believe this is for Ms. Ridings. Can you talk about for an April 30th launch, when would that red arrow that you talked about on the slide for the racetrack that you're doing, about what time after liftoff, sort of mission off time, would that begin?
Okay, so for an April 30th launch, launch is 11:22 a.m. Central Daylight Time, and you get to right before the red arrow is on the order of 39 hours. So if you were using shuttle nomenclature, which the NASA folks still do, it'd be a flight day 3 fly under. So flight day 1 launch, flight day 2 is really, we call it far field phasing, flight day 3 fly under, so 39 hours. The fly under itself is on the order of 3 or 4 hours where we're gathering that data. And then if you remember kind of from the red arrow all the way around, roughly 22 hours. And so you're coming back the next day really for a flight day 4 berthing, rendezvous and berthing. So I'll go through it one more time. Slower, flight day 1 launch, flight day 2 phasing, flight day 3 fly under, which is May 2nd in our scenario, and then a flight day 4 proximity operation, rendezvous and berthing, so May 3rd. The capture itself, kind of early morning, Central Daylight Time, 7:30. Of course, crew day, that's kind of midday crew day. So the activities will start pretty early in the morning, Houston time, and even earlier in the morning, California time. But the capture would be about 7:30 a.m. In the morning is what it'd be planned for on that May 3rd.
Thanks. And I believe if I understand this correctly, there's the primary opportunities on April 30th, and then there's a secondary opportunity on May 3rd. Can somebody explain why there isn't a daily launch opportunity for this mission, and is this just a mission-specific thing? Thanks.
Here, yeah. So I'll talk about it a little bit. So some of it is mission specific because of the demonstration. As Elon talked about, this is definitely the demonstration, and so there's a lot more things on this flight the fly under is one of them. Some of the objectives that we're performing, the analysis that needs to be performed of the data that's gathered on orbit. So the fly under is unique to this demonstration mission, and so that really kind of helps figure out exactly what the launch dates are. The SpaceX team's also reserving some margin that they can talk about, Elon can talk about a little bit, just for contingencies. Again, it's a demonstration, and they want to make sure they've got enough margin if they need it on orbits. We're also always working on the ISS trajectory. So we've got Soyuz flights coming and going. We've got Progress flights coming and going. We've got ATV activities, as was articulated earlier. And so the ISS trajectory is in flux as well. So when you add up all of those different components, you end up with these kind of just smattering of launch dates in the early May timeframe. After the demonstration is complete and we look at all the data, potentially we'll be able to find those back-to-back type things that you were used to with shuttle, but we've got to gather a bunch of data before we can get to the point where we understand that in detail.
Yeah, I mean, I can say in future missions there'll probably be more something closer to daily opportunities, but for this mission we want to have a really optimal launch, so we're minimizing the propellant usage getting to the space station, and that tends to occur roughly every 3 days. So we just want to have as much propellant available in case something goes wrong and we need to make adjustments to the mission. Yeah, so that's why the 3 days.
Hi, it's James Dean from Florida Today, and just following up on that topic, I wondered if, I understand, I guess, that you have April 30 and May 3 as the first couple of opportunities. Just wondered if you could elaborate any further on if there are any scrubs or anything like that. Are there any blackouts due to the range or the Soyuz launch or any other issues? And so, when did the opportunities fit into the rest of that schedule?
So I can go ahead and take that one as well. So there's actually a little bit of all of those things. There's certainly range conflicts. There are always range conflicts. There are some beta cutouts in terms of a space station. There are some ground rule and constraint type cutouts where we don't want a Soyuz vehicle and the Dragon vehicle exactly on top of each other. We've got to make sure we get one activity completed before we start the next one. The Dragon has some constraints as well for their recovery, where at least for this demonstration, they'd like to land in daylight to help them out with the recovery operations. So there's multiple constraints on the table that we need to line up in order to find an optimized launch window for this demonstration mission. So the answer to your question is kind of all of the above.
Okay, thanks. And then for Elon, this flight, of course, it's not unusual for things to slip a little bit, but you were targeting November at one point and then February. And just wondering, what has proven to be most difficult for you to get to the point where you're ready to go? If any aspect of this was a surprise to you at how hard it was. And just as a slightly unrelated question, I was wondering if there are any plans to recover the first stage.
Oh, sure. So, well, I should point out that the rocket is definitely not the constraint. I mean, we could have launched several rockets, Falcon 9 rockets last year if it had just been the rocket. And it obviously wasn't the elements of the Dragon that have been tested before, the Draco thrusters or the heat shield or parachutes or anything like that. The tricky part was really related to the proximity operations and berthing system, so that there's the LiDARs, for example, which is kind of like laser radar, thermal imagers, the communication system, making sure that we can communicate effectively with the space station, with the ground, and with the NASA TDRS system. There's a lot of basically electronics, new electronics on the spacecraft. And it's also the first time we're flying the solar arrays and the radiator system. So those are new elements to the mix. But the thing that really drives the schedule is the software testing, development and testing, and how that interacts with the hardware. That's where the phrase hardware in the loop testing, that's what it refers to, is does the software always do the right thing in a particular circumstance? And when you've got 18 engines and you've got effectively sort of 6 flight computers and a whole bunch of other systems, just the test matrix of that is enormous. And a lot of people don't realize that Dragon is autonomous. I mean, it's really it's a robotic spaceship, and it's going to go and do this complicated maneuver where it's going to berth with the space station. It's not as though there's somebody flying it with a joystick, or that there's somebody on board that can make kind of real-time corrections. Dragon is kind of is making lots of decisions all the time to optimize the probability of success. So there's a lot of intelligence on board the spacecraft, and all of that has to be tested thoroughly, and that's the biggest driver of the timeline.
Okay, I think that's it at the Kennedy Space Center. We're going to go to the phone lines now. Let's start off with the Washington Post and Ryan Vastag. Are you there? All right. Let's try Wired Magazine with Jason Parr.
Yes, I don't know if this might be for Holly. Early on, it was talked about some of the work that's being done or the training that was done for the crew on orbit. A lot of that took place on the ground. You said, I'm curious, what sort of preparations are being done while in orbit? I mean, is there any way for them to practice any of the maneuvers? What type of training is done while they're on orbit?
Okay, so the answer is yes, there is the capability for them to practice on orbit. They practice with the actual robotic arm, so the SSRMS. They do some grappling practice, again, sort of line up and pretend that the Dragon is there, and so they know exactly, looking out the window and looking at their computer screens, what the arm half of that equation is going to look like when the Dragon arrives. They also have a simulator that they practice with, because certainly the robotic arm is a significant resource, and so we do have an internal simulator that they can practice, so they can do multiple runs, some very complicated contingencies that we wouldn't want to put our robotic arm in, or that can't be done without the Dragon actually there, some abort type scenarios. So again, they know exactly how to react. So those are their 2 primary methods of training. They also do some scenarios where they set up all their computers and all their cameras, more the familiarization type training, to make sure they have quick reference marks, they can find all the data they need rapidly, and then they do some self-study as well. So again, kind of that building block approach to hardware use, all the way to the self-study with the procedures and talking to the folks on the ground.
Up on the whole the demonstration maneuvers, and the graphic you showed with the Dragon going from 250 to 220 and then 230, 10 meters. If any of those particular rehearsal maneuvers don't go correct the first time, is there the ability to retry the demonstration, or is it sort of a one-shot attempt?
So the answer is a little bit of both. The demonstrations, some of them occur, you were talking about the ones on the R-bar, some of them occur early in the mission, shortly after Dragon gets on orbit. Those activities will take place, the data will be gathered, it'll be submitted from the SpaceX team to the NASA team. Certainly if we did not see something that everyone agreed to was acceptable, the SpaceX team might have the capability to retry those as part of their phasing plan. That would be somewhat dependent on the margin they have before they get close to the space station. If we were flying under the space station and were unable to gather the data we needed, it could be done again, but it would require going all the way around and flying under again. But certainly that would be an option if we had enough propellant to do that. And the ones on the R-bar that you mentioned, those, in order to go ahead and complete the berthing that day, need to go pretty quickly. So if they, mostly because sitting again on the R-bar is not a very good place to stay for a long time in terms of your propellant usage. You use a lot of propellant sitting in that area, holding your position underneath the space station at about 250. So if they didn't go well, it would not immediately mean the mission was over, but it would definitely mean you could not continue at that point in time. So it might be that the Dragon would go off and potentially start another fly around, and we would talk about maybe coming back and trying those demonstrations again the next day. So it's absolutely a gate to come on in. If it did not go well, we would look at the consumable resources and work with the Dragon team and see if there was anything we could do to potentially repeat or gather additional data that might help us understand the problem that we'd seen the first time.
Okay. Scott Powers with the Orlando Sentinel.
Actually, I think my question has been resolved, but thank you very much. Okay. I appreciate it.
Mike Wall with Space.com.
Oh, yeah, hi. So today I was interested, Elon talked a little bit about what some of the challenges were from the SpaceX side for this. I'm just curious, what have some of the biggest challenges been on the NASA side, since this is such a new mission for you guys and you're not responsible for the entire thing from start to finish? What sort of difference has that made for you guys, and sort of what are some of the biggest hurdles to have overcome with this one?
Well, I'll go ahead and answer that one. To begin with, it's just getting used to the idea that we're not worrying about the entire phase of the flight is an adjustment to begin with. Probably the biggest difference, once you settle on that aspect of it, probably the biggest difference is we're verifying a system based on requirements we gave for performance, but in terms of developing the hardware, the design of the hardware, how individual boxes are laid out, the design concept, the components that were used, that's not the kind of information we have access to. And so it's been kind of an adjustment for our engineers to create requirements and validation steps that give you confidence in the robust nature of the design that's being flown. And so that was probably the biggest adjustment that we made. It's been, as I mentioned earlier, it's been really kind of a fascinating process, because you begin with this group of engineers that have been doing this business for many years, who have gotten information passed on from the engineers before them that have done this job a certain way, with a complete push towards safety and mission success, because each flight was so very expensive that while safety was critical, mission success was very important. And everything from the procurement of Triple-E parts all the way up to the integrated performance testing of a system, and how you're going to put it together and how it's going to react to anomalies, all that was something that you spent many years in your mind perfecting. And then to go sit with another company and say, this is your requirement, and then have that group of very clever engineers, many of whom maybe don't know that much about space, many of them who did, but all of them very young, have them say, well, why? And instead of the NASA engineer being able to say, well, this is how we did it, the question was, why do you do it that way? And so when that exchange took place, it was quite enlightening experience for us both, because once it was clear to the SpaceX engineer what it is that the NASA engineer was trying to protect against, then the light bulbs would come on and go, oh, okay, well, in order to solve that issue, this is how I do it with my design. And then the NASA guys would learn from that. And so the biggest piece of it, I think, from my perspective, and it's not a bad thing, it's just an adjustment, and I think actually it's been good for both sides, is that we've learned, or we kind of had our eyes opened up to different ways of tackling similar problems, and in that respect it's been very beneficial. But I would tell you that it's an adjustment not to have the very detailed design data that we're used to when you actually design the hardware, and we're more looking at it from a performance standpoint.
And I would add one thing too, a little bit, is that the space station team got to see a piece of this as we put modules on board space station. Again, the international partners built to a set of our requirements, but they accommodated those requirements in a potentially different way than we did. So in a non-maneuvering vehicle kind of standpoint, the station team got a chance to see how to work with a set of with a partner that essentially answers the how to our requirements. And Mike's discussion was very good about how both teams have really learned from each other. I get a chance to kind of sit back and watch both teams learn from each other, and it's been a tremendous learning experience for both of us. I think we've learned new things on the NASA side, some things we've always done a certain way, and then when we get asked now, why do you really do that requirement, it's really forced our folks to go think about it, and we're starting to kind of internalize it. Hey, there may be another way of doing some things that are better. So we've definitely learned some things from SpaceX, and hopefully I think they've learned some things from us as we go through. So as a good partnership, you learn from each other, and you end up with a much better product coming out the other side.
Okay, how about Michael with Popular Mechanics?
Hi, I wonder if someone could break down more specifically what's cargo is going to be on the flight, what sorts of hardware, and also are there going to be any crew provisions on there too?
Well, in fact, primarily it is crew provisions. We're flying quite a bit of food. Crew provisions, some replacement consumable type components. We have one Nanorex payload that's got some, it has a number of student experiments on it. That's the lion's share of it. A lot of it is food, but the majority of it is actually food and crew provisions.
What's the total weight again going up and then coming down again?
It's 521 kilograms of cargo up and 660 kilograms down. And the down manifest is not completely finalized. One of the things that happens once you get to orbit is you sort of agree on the mass down and the biggest drivers of that mass, knowing that once you get there you might change that a bit. But as I mentioned earlier, we do have some, while we kept away from putting one-of-a-kind orbit replacement units or major components on the ascent side, we actually did put some ORUs on the return side in hopes of getting them home so we could refurbish them. They're not required, but in a couple of cases, if we can get them home and refurbish them, it'll save us money, because otherwise we would have had to procure that spare. That's certainly in our plan, and our budget is to procure the spare, but this was a chance to try to get some home and save some money. So we actually do have some ORUs coming home on the down manifest.
What are ORUs?
Those are the replacement spare components to replace components on board. We have a pump, a couple of multi-filtration beds that were in the water processor, and our JAXA colleagues have a power supply box for their communication system on orbit that's also coming home.
Great, thanks a lot.
Okay, Lisa Grossman with New Scientist. Lisa? Okay, Jason Davis with Planetary Society.
Hey guys, you had talked about some of the gates and specific checkpoints that the Dragon would be required to go through during each stage of the approach, and I just wanted to know who holds the final authority to make decisions during a contingency. Has that already been planned out in advance, or are there situations where a single party, either NASA or SpaceX, would have to make a decision on how to proceed? Thanks.
And I'll take that one. So it certainly depends on where you are in the mission. If it's very early in the flight and the launch and that far field phasing where the Dragon is not near the space station, then it's the responsibility of the Dragon team and SpaceX. But once the Dragon arrives near the space station, and near is kind of defined by my graphic, it's coming up about 10 kilometers below the space station, then there are, and actually during the fly around, there are go, no go points. Again, I defined that earlier as we take a poll and make sure we've got all the capabilities. And all of those go, no go points, the team here in Houston, per our documentation, holds the final authority. There's also a couple other cases if we do have an abort, something that is unexpected, that the Dragon needs to leave the proximity of the space station, and then the Dragon team can figure out that issue and put the Dragon back on a trajectory to potentially make another attempt. That process, Houston has authority over that process. And then if anything were to go really unexpectedly wrong with the space station, even if the Dragon is fairly far away from us, we would exert some authority in the sense of telling them we're absolutely not going to be ready for you anytime soon, so we don't want you to come up too close to us. And so there's kind of the very specific predefined items, again, those go, no-goes that are in our flight rule that are those height adjust, again, the burns, the maneuvers the Dragon performs as it comes increasingly closer to the space station. There are those points predefined as it flies around the space station, and those points predefined as it comes up to do the final rendezvous and the berthing and the proximity operations. And then there's those generic catch-alls for if something goes unexpected. And all of that has been discussed with the team in Hawthorne and our team here in Houston, and is all written down in our documentation that we fly with, our flight rules.
Okay. Jean-Louis Santini from Agence France. How about Kelly Sheraton? Okay. Eric with Nature Magazine. I'll keep going. Stephen Clark with Spaceflight Now. Maybe they got tired of the music. Ann Walters with the German Press Agency. How about Irene Klotz?
Thanks, Josh. I am here. I have a couple questions for Elon. The first is, including that $381 million from NASA, how much more money has SpaceX spent to get to this point in the development? And overall, what do you think the odds are that this mission will be completely successful in terms of docking at station and a successful retrieval after splashdown?
I don't have the exact number that SpaceX has spent, but we have raised several $100 million in venture capital, the initial part of which came from me, and then there's been ongoing payments for other milestones that have been achieved for NASA and for other customers. I think probably the total amount spent cumulatively would be somewhere around $1 billion. So that's cumulative over the life of SpaceX. And then in terms of the probability of success, I have some hesitation about giving an exact number, since they're pretty big. There's a pretty big range, I think. But yeah, I personally hesitate to give an exact number. But I mean, I think that the likelihood that the rocket works is pretty good, since it's worked twice before. Likelihood of the spacecraft, the non-berthing, or portions of the spacecraft that have been flown before working, is also quite good. But then there's much more of a question mark around the proximity operations and berthing system and the solar arrays, which are being tested for the first time.
For either Bill or Alan, could you just refresh my memory and tell me what it would cost approximately, based on, I think GAO did a report, if NASA had developed a similar capability under a traditional cost-plus award fee contract?
Well, there were studies done that said if you use our traditional modeling and our traditional approaches and assumptions, it could have been anywhere from 4 to 10 times higher under a traditional NASA development.
Thanks very much. Good luck.
Okay, thanks, Irene. Is there anybody else on the phone line that did not get a chance yet or would like to ask a follow-up?
Hey, Josh. Bill Harwood with CBS.
Hey, Bill. Go ahead.
Oh, thanks a lot. Two quick ones for Holly. If the Atlas stays on the range where it is, and if Soyuz stays where it is, which they will, and if SpaceX doesn't get off in those first two attempts, when would this guy slip? How far would it slip? I'm assuming after Soyuz, and it wouldn't be a way to get it in between Atlas and Soyuz. Is that right?
Yeah, so I mentioned earlier there's quite a few variables. In general, yeah, there's a window kind of this late April, early May, which is the one we've been talking about with the 30th and the 3rd and you know, potentially some options. I know the Atlas is in there. And then there's an after Soyuz window kind of in the, you know, mid to late May time frame. And you know, mentioned earlier a lot of the variables and all of those need to line up, but those are the two windows that are the high probability ones that we've been looking at right now.
All right, and one more quick one for you, and this will do it for me, Josh. Can you give us a little bit better sense of what sort of issues you guys have been working on the last couple of months with SpaceX? I mean, obviously they wanted to launch in February, and it slipped a bit, and I've never heard any good details about what sort of things everybody was trying to get resolved. It took the extra time. If you could give me some sense of that, I'd appreciate it. Thanks.
Okay, well, I can certainly tell you from an operational perspective, a lot of the capabilities that the SpaceX team wanted to work on were their mission success capabilities, things that Elon can probably tell you are very important to them. So when they came with those capabilities, that obviously requires a joint sort of review and determination. One of the ones we talked a lot about was recovering from abort type scenarios. Those capabilities are complicated and difficult, and we'd done some preliminary work, but we really took this extra time to make sure that we've got a real solid plan so that we've got a higher probability of being able to work together to accomplish their primary objective, which of course is the success of the mission. And so we made our teams here, the operations team as well as other teams, available to really talk through some of those items. That's my example, and I don't know, Elon, if you have others. That's really the one we've spent probably the most time on in the operations world talking about, because it's very important. We want to be able to do that as a team in the event that we need that capability.
Yeah, I think it's like I said earlier. You know, it's really just about the hardware loop testing and validation of the software. That's the biggest driver. I mean, there were other things that were done in that time, but just testing a vast amount of intelligence that's occurring in the software, and making sure even in highly unusual situations that the mission is successful, at least in the simulation. That's what's taken the most amount of time, and it's just a very, very complex system.
Okay. Thanks, Bill. Is there anybody else on the phone lines? All right, let's come back here to Houston. We'll start back over here with Mark.
Thank you, Mark Carreau, for Aviation Week. I guess I'm a little hazy on whether there's an MMT authority during the flight, or if that is the space station, IMMT, that sort of is the big picture supervision.
It's the space station IMMT.
Thank you.
Eric Berger again with the Chronicle. A quick question for Bill or Mike. Could one of you address the feeling inside the space program with this launch coming up? Because this is an American company, and obviously there's been a lot of heat on NASA in the last couple of years relying on Russian rockets for humans, and this is a potential way out of that. Is it something that a lot of people are looking forward to, or how would you characterize the mood sort of leading up to the launch?
You want to do mood, or do I do mood?
You can do mood.
Thanks. Well, you know, from our perspective, what you're referring to is probably a combination of perceived emotions way back when we started down this road, because it had to do with getting out of the space shuttle business and getting into a commercial venture, and that probably played a little bit of the role of a misconception and perhaps not everybody being completely behind this effort. But I can tell you from a program perspective, and those are the people that I see and talk to every day, we couldn't be more pleased with what we're off to go do. And the reason is, it provides indigenous capability within the U.S. to supply the ISS, which we think is very important. It does have implications to to human transport again to ISS. It's commercializing, if you will, helping commercialize a low Earth orbit, which we think is a very important need and something that NASA is responsible for. And some of us, and in particular myself, believe this is a very important step for us to take in order for us to do exploration in the future. NASA needs to develop or encourage a capability and help the development of a capability, of a commercial capability to support low Earth orbit, both in terms of cargo and humans and other capabilities, robotic servicing, things like that. And NASA needs to start focusing on human exploration beyond low Earth orbit. And so those of us who are looking forward to the next step for NASA really are very excited about this next step for the space station. And we believe this is, in order for space station to be successful, these systems have to be there for us. And so we look on it very favorably and are very excited about this pending launch.
I think I'd add just a little bit, you know, this is absolutely critical to space station. We really need this cargo capability to be able to get to station, and the return capability that Dragon provides is truly unique of any one of the cargo providers, including the Russians and Soyuz. The amount of cargo we can get back with Dragon is just phenomenal from a return standpoint. So we absolutely need this capability for ISS, and we're really rooting for the teams to come through. I think it's also been encouraging to see SpaceX to work hard issues. You know, they had some EMI, electromagnetic interference issues that they worked, and they spent some really good engineering time to resolve those issues and get them resolved. They had some engine delamination concerns, and again, they were very rigorous. They tested some things that maybe you didn't absolutely have to go test, but they wanted to go test them to make sure that they were right. That's really encouraging. So I can really, you know, get behind somebody that's doing that extra work to get ready to go fly. But as Elon said, this is really a tough flight. I mean, what we're asking them to go do on this demonstration flight is amazing. When you look at all those things that Holly talked about on her charts and the many hours that all this hardware has to work and all the software has to interact, and the 6 computers and the 18 thrusters and all this has to work as a nice combined set to get into this precise box to be picked up by the SSRMS, that is no easy task. So this will be a very demanding mission, and we need to look at it as a test flight. It's what it should be. We'll see how well the test works out, but they've really done a good job in getting ready for this test. So as a NASA team, we're ready to watch, participate, and help, and we truly need this capability for ISS.
David?
Yeah. And just to get a more detailed sense of where we are technically today as of this meeting, the hardware in the loop issue that you were describing a little bit earlier, does that relate specifically to something on the timeline that Ms. Ridings was taking us through earlier, a specific element there, or is that, as you're saying, maybe something that's more generalized over the entire mission?
Yeah, so hardware in loop means, just to give a little more color on that, essentially we have a complete replication of the Dragon's avionics system on a bench, and then it flies a simulated mission, and it actually it's like a sort of like a brain in a tub thing. It actually thinks it flew to the space station, and it does, and we watch to see what it does. Does it do all the right things on the way to get there? And if it doesn't, then where did it go wrong? And what happens if we unplug certain devices, essentially simulating failure at the worst possible moment? Does it then take the proper steps? And then what happens if you fail several simultaneous things? And what if you fail something and then restore it? There are many. The cross product of all those things is a huge number of tests. So there's just. You're
introducing failures.
We introduce failures, yeah.
So there's nothing along that timeline, just to move it along, because I know it's getting late here, that in Ms. Riding's timeline that you're specifically focused in as far as a mission element that might be problematic. You just need to introduce more failures and troubleshoot that and see how the system's going to react.
Right, exactly. In fact, the recent, say in the last month or so, the tougher things have been to deal with false aborts, where it actually initiates a mission abort because it was too sensitive to the parameters. So things were actually okay, but Dragon got too worried and aborted the mission. So
You're from LA, so.
Right. So it's, you know, you don't want to have, it definitely needs to abort if something's wrong, but sometimes it may think something's wrong, but it's actually okay. And there are all sorts of, and there are all different types of failure. Like I said, you can have something fail and stay off. You can have something fail erratically, where it goes off and comes back, and sort of oscillates. You can have multiple things fail at the same time, and the system has to be able to deal with all of those contingencies.
Okay, is that it here in Houston? Okay, before we finish up, we're going to take a look at our launch and mission coverage that we have upcoming here on NASA television. Coming up at L-1, there will actually be a pre-launch news conference from the Kennedy Space Center. And then on Monday, April 30th, at 10 a.m. Central Time, that is when our launch coverage will begin. And once again, launch actually scheduled for 11:22 a.m. Central Time right now. And then at 1 p.m. Central Time, we'll have a post-launch news conference from KSC as well. On Flight Day 2, which right now should be Tuesday, May 1st, we will not have any live coverage here on NASA television, but we will have an update during our typical daily ISS update show here at JSC, which will air at 10 a.m. Central Time, 11 a.m. Eastern. And then on Wednesday, May 2nd at 1:30 a.m. Central Time, very early in the morning, we'll have our fly under coverage from here at the Johnson Space Center inside Mission Control Houston. And at 9 a.m. Central Time, we will have a mission status briefing here at JSC as well. And then finally, Thursday, May 3rd at 1 a.m. Central Time, that is when our rendezvous and berthing coverage will begin here at the Johnson Space Center, once again from Mission Control Houston. And then at noon Central Time, we should have a mission status briefing again here at JSC. Of course, all these times are subject to change. To see all of this and to also see any of the slides that you saw today from our participants, just log on to www.nasa.gov/SpaceX, all lowercase. It's important that you do that. If you look on the right-hand side of the page down at the bottom, there's a media resources section. You can find all these slides as well as the press kit once we get it finished up and posted there, as well as the NASA TV schedule. So just log on to there to get all of the latest. I want to thank all of our participants for joining us today, and we'll see you back here in a couple of weeks for the SpaceX mission. Thank you.